In this video, I am explaining about schematic arrangement of thermal power station. Schematic arrangement of thermal power plant. The whole arrangement can be divided into 6 main stages. One is coal and ash handling plant. Second one is steam generating plant. Third one, steam turbine. Fourth one, alternator. Fifth one, feed water circuit. Sixth one, cooling arrangement. This is the entire schematic arrangement of thermal power plant. The first stage of the circuit, it is called coal and ash handling plant. In the coal and ash handling plant, we are having the coal storage plant and coal handling plant and ash handling plant and ash storage plant. In the coal and ash handling plant, the coal is transported to the power station by road or rail and is stored in the coal storage plant. From the coal storage plant, coal is delivered to the coal handling plant where it is pulverized. Pulverized means we have to cut the coal into the small pieces. And that coal, in order to increase that pulverized coal, in order to increase its surface exposure, promoting rapid combustion without using large quantity of excess air. The pulverized coal is fed to the boiler by belt conveyors. The coal is burnt in the boiler and the ash produced after the complete combustion of coal is removed to the ash handling plant. And then delivered to the ash storage plant for disposal. The removal of the ash from the boiler furnace is necessary for proper burning of fuel. The second one is the steam generating plant. The steam generating plant consisting of a boiler for the production of steam and other auxiliary equipment for the utilization of flue gases. In the steam generating plant, we are having the boiler, superheater, economizer, and the air preheater. In the boiler, the heat combustion of coal in the boiler is utilized to convert water into the steam at high temperature and pressure. And the obtained byproduct from the boiler is the flue gases. This one passes through the superheater, economizer, air preheater, and finally exhausted to atmosphere through the chimney. Regarding the superheater, the steam produced in the boiler is having some wet. To remove that wet, it is passed through the superheater. In this superheater, the steam is dried and superheated, that is, steam temperature increases above that of boiling point of water. In this superheater, it is superheated by the flue gases on their way to chimney. The steam is superheated because by this we will get two benefits. The overall efficiency is increases. Too much condensation in the last stage of turbine, which would cause blade corrosion, is avoided. The superheated steam from the superheater is fed to the steam turbine through the main valve. Steam turbine through the main valve. And regarding the economizer, an economizer is essentially a feed water heater. It drives heat from the flue gases. The feed water is fed to the economizer before supplying to the boiler. The feed water is heated by the part of the heat of flue gases. Then coming to the air preheater, an air preheater increases the temperature of the air supplied for coal burning. It also deriving heat from the flue gases. The complete function: air is drawn from the atmosphere by a forced draft fan and is passed through air preheater before supplying to the boiler furnace. It also extracts heat from flue gases and increases the temperature of air and sent to the boiler furnace for coal combustion. The principal benefits: it increases thermal efficiency. Increased steam capacity per square meter of boiler surface. And the third one, that is the steam turbine. Regarding the steam turbine, whatever the steam obtained from the superheater, that is superheated steam, is fed to the steam turbine through main valve. The heat energy of steam when passing over the blades of the turbine is converted into the mechanical energy. After giving heat energy to the turbine, the steam is exhausted to the condenser. The function of the condenser is it condenses the exhaust steam by means of cold water circulation. And the fourth one, that is the alternator. Regarding this alternator, the steam turbine is coupled to an alternator. This alternator converts mechanical energy of turbine into the electrical energy. The electrical output from the alternator is driven to the bus bar through transformer, circuit breakers and isolators. And the next one is the feed water circuit. The condensate from the condenser is used as feed water to the boiler. At middle, that is between the feed water on its to boiler, is heated by the water heater and the economizer. The purpose is it increases the overall efficiency. Here, in this, some water may be lost in the cycle, which is suitably make up for external sources. The next one is the cooling arrangement. In order to improve the efficiency of the plant, the steam exhausted from the turbine is condensed by means of a condenser. Water is drawn from the natural sources of supply such as a river, canal, or lake and is circulated through the condenser. The circulating water takes up the heat of the exhausted stream and itself becomes hot. The hot water comes from the condenser is discharged at a suitable location through the river, down the river. In case the availability of water from the source of supply is not assured throughout the year, cooling towers are used. During the scarcity of water in the river, hot water from the condenser is passed on to the cooling tower, where it is cooled. The cool water from the cooling tower is reversed in condenser. Thank you.